Okay, so this video is meant for my geometry students. We do have a quiz on Thursday over sections 3.1 through 3.4, so this is to help you prepare for that quiz, along with your note cards and making sure that your notes are properly completed. Okay, so here's the first problem. This picture should be familiar to you. It's this barn problem that we had in the homework, and I'm going to ask you three things. First, give me a segment that is skew to segment AE. All right. Well, remember the difference between skew and parallel is this idea of being non-coplanar. Okay? So the idea is non-coplanar with AE. But they still can't touch either, okay? So if I look at this picture, there are several to choose from, okay? Because AE goes vertically up and down. So pretty much any segment that's not going to intersect AE but doesn't go vertical and doesn't go vertical is a good choice. So if I look at this back plane, I'm going to go to this back plane and I'm going to pick HG. HG is a segment that is non-coplanar, right? I could not draw a plane between those two things. They're not going in the same direction. And this AE is going to go up and down. This HG is going to go diagonally, but they're one's in front and one's behind the other, so they're never going to touch. So HG is an answer. Another answer might be, here's AE, what about CG? They are non-coplanar. AE is going up and down. CG is going left and right, or you know, coming at you and going behind you, going away from you. They're never going to touch. They're going different directions. All right. So there's skew. Now let's move on to being parallel to AE. Well, that means that you have to be in the same plane as AE. So I would just look at this front one and I'd say, okay, let me try this blue. CD is a parallel segment to AE. So CD would work. Another one that might work, okay, go to the plane on the side. AE and IJ. IJ would also be a parallel segment. And finally, let's look at some parallel planes. Okay, if I look at this picture, let's go with the front one and the back one. They're parallel planes. So we name planes with two letters, right? So plane, or three letters, I'm sorry, three letters. So plane A, B, C is parallel. So ABC is the front one, is parallel to plane, and I'll just go in the same direction, IHJ. Or IHG, I'm sorry, IHG. So plane ABC is parallel to plane IHG. So there's skew, parallel, and parallel plane. Okay, so let's take a look at this picture over here. In this picture we have a pair of parallel lines. We know that from the, we know that from the red arrows. Okay, they are parallel. Right here, these two lines. We have a transversal, and we have one angle measure, 51 degrees. And the question is, what are these three angle measures, and tell me why. Justify. Remember this idea of justify. Okay? Well, angle 2 is right here. If I look at angle 2 and the 51 degree angle, they are same side interior angles. Same side interior with the 51 degrees. So to find the measure of angle 2, I need to take 180 and subtract 51. And when I do that, I get 129 degrees. And there's the measure of angle 2 because that it's same side interior with angle 51. Okay, what about angle 5? Well, angle 5 and the 51 degree angle, they are corresponding angles. And corresponding angles are congruent. So angle 5 is the same as 51 degrees. And then lastly, angle 7. If I look at angle 7, hey, it's not one of the special four, it's one of the old school angles. Angle 7 is vertical with angle 51. Don't forget about those relationships. Vertical angle with 51 degrees. Vertical angles are congruent by the vertical angles theorem, so it's also 51 degrees. Okay? So again, I cannot stress enough to justify if I ask you to. Okay, so here's the third one, our first two-column proof of the review. In this proof, I give you that lines A and B are parallel, so that'll be my first reason in the proof that A is parallel to B, or that's my first statement, and that's given. And again, in my mind the whole time is what I need to prove. Okay, I'm not going to write it down here because I might run out of room, but I need to prove that. So again, I'm going to look at this picture and say, what are all of the relationships that I know? Well, I know because lines are parallel, 1 and 5 are congruent because they're corresponding. Okay, I know that 5 and 7 are congruent because they're vertical. And then if I look at 5 and 8 and 7 and 8, 5 and 8 are a linear pair, 7 and 8 are a linear pair. So those angle pairs, 5 and 8 and 7 and 8, are supplementary. That's because they're linear. So I know all that information. So the question is, how can I get angle 1 and angle 8 equal to 180? Well, if I look at what I'm thinking about, you should see two things that stick out at you. This and this. And the reason those two things should stick out at you is because they involved angles 1 and 8, and they both have 5 in them. So let's you go with this idea and see what we can do. Okay, so because the lines are parallel, I know that angle 1 and angle 5 are congruent because of corresponding angles. Now I'm going to jump straight to equality because I know I have to use this step. So if they're congruent, they're also equal. So the measure of angle 1 equals the measure of angle 5. It's because these lines are parallel, and angle 1 and angle 5 are corresponding angles. Corresponding angles theorem. So now, I need this statement. Measure of angle 5 plus the measure of angle 8 equals 180. And again, I prefer that they're a linear pair, so it's the linear pair postulate. But, I mean, it's up to you, okay? And now, I use both my thoughts. So now I have to combine my thoughts somehow. Well, look, if angle 5 is here, and angle 5 is here, look here, angle 1 is the same as angle 5. I want angle 1 to be with that 8. Well, just substitute it because we can. Because we know 5 and 1 are equal. The measure of angle 1 plus the measure of angle 8 equals 180. And that's a substitution. And what did we do? We just proved that angle 1 plus angle 8 equals 180. And we started with parallel lines. Okay, so here's this problem. You have this picture. We have two lines, L and M, cut by a transversal. The question is, what would be the value of x so that L would be parallel to M? Well, let's think. Those two angles right now are alternate interior angles. So to prove lines parallel, we always use a converse. Converse to alternate interior angles theorem. Okay, this is our reasoning here. That's our justification. So we need to understand that to use this, what has to be true about alternate interior angles? Well, alternate interior angles must be congruent. If they are congruent, then the lines are parallel. So let's find the x value that makes them congruent. To do that, we solve this equation. 2x minus 5 equals 95. We set them equal because they need to be congruent. I'll add 5. 2x equals 100. I'll divide by 2. And x is 50. And according to this picture, if x is 50, we will get congruent alternate interior angles. Now we can check, right? 2 times 50 minus 5, that's 100 minus 5, which is 95. Makes this angle 95 degrees, which makes these two angles congruent. Those are alternate interior angles. If alternate interior angles are congruent, then your lines are parallel. There we go. So there's our x value. Okay, so here's the next problem. It gives us this picture with 4 lines, whole bunch of different angles, and it says, okay, which lines are parallel? And we're given that angle 1 is congruent to angle 3. Okay, so on my picture, I'm going to mark angle 1 is congruent to angle 3. Well, hopefully we can recognize that these are corresponding angles. So to prove lines parallel, we use the converse to corresponding angles theorem. And those angles better be congruent, which they are. So we know that some lines are parallel. So the question is, which ones? Well, I always say, what is your transversal? The transversal is the line that both angles are lying on. And that would be L. L is my transversal. Therefore, L cannot be a parallel line. So L and M are automatically ruled out. What are my parallel lines? My parallel lines are A and B. A is parallel to B, and that is because of the converse to the corresponding angles theorem, given angle 1 congruent to angle 3. Identify those transversals every time. Okay, so here's the proof. We have to write a two-column proof. We're given two things. L is parallel to N, angle 12 is congruent to angle 8. And we need to prove that J is parallel to K. Alright? So here's my picture. Two sets of possible parallel lines, right? So let's write down our given. We are given that L is parallel to N, and angle 12 is congruent to angle 8. That's given to us. And let's go ahead and mark that on the picture. I'm going to mark it in red. L is parallel to N, and 12 is congruent to 8. Okay. Alright. So hopefully you see that we have to prove this. And if we have to prove that, that means a converse has to be used because we're proving lines parallel. So we need to figure out how can we relate two angles together in one of those four special relationships so that we can use a converse to show that the lines are parallel. Okay. Well, let's start off with this angle, this lines L and N. Here's line L, here's line N. There are two transversals, J and K, right? Two transversals. Only one of them has two angles on them, and that is transversal K. So focus on K as the transversal. K is your transversal, so let's see. 4 is here, 8 is here. Are those a special kind of angle? I think so. They're corresponding angles. And since these two lines are parallel, these corresponding angles will be congruent. Now, notice how I'll do it. Well, we'll put angle 4 is congruent to angle 8. And this is because they're corresponding. And now, look at your given. 12 is congruent to 8, and 4 is congruent to 8. So 12 and 4 are also going to be congruent. So look, 4 is congruent to 8. Put a marking here with 4. So now look at 12 and 4. 12 and 4 are congruent. So now, if you look at 12 and 4, the transversal now is L. And 12 and 4 are corresponding angles for lines J and K. So J and K are going to be parallel because of the converse to corresponding angles. So that's the reason, that's the converse we're going to use. But now we have to put all this together, okay? So again, if lines are parallel, then what of those four relationships is true? Well, we said that since L and N are parallel, K is our transversal, angle 4 is congruent to angle 8. Now, I'm going to put it strategically like this. Angle 8 is congruent to angle 4. Doesn't matter, but I'm using this idea right here. And that's because if lines are parallel, corresponding angles are congruent. That's the corresponding angles theorem. Okay? So now, put your two statements together. If 12 is congruent to 8, and 8 is congruent to 4, then 12 is congruent to 4. That's classic transitive property. Classic transitive property. Okay? And now, look at your picture. 12 and 4 are on line L. They're corresponding angles that are congruent. So we have the ability to prove lines parallel by using the converse to the corresponding angles theorem, right? Proving lines parallel is a converse. So what are the two parallel lines? Well, L is my transversal, so J and K are the parallel lines. And that is exactly what you want to prove, and we used all our thoughts. And life is good. We've completed this two-column proof. Okay, last problem I have for you, two parts. The question is, how does A relate to D? Okay, and we have to use these theorems that we learned in section 4. The transitive property of parallel lines, the fact that if one line is perpendicular to if two lines are perpendicular to the same line, then they're parallel. And then the last one, if one line is perpendicular to one of the parallel lines, then it's perpendicular to the other parallel line. Okay? So here's what I'll do. I'm just going to go left to right order, and let's see if it works. Okay? So let's start here. If A is parallel to B and B is parallel to C, then we should know that A is parallel to C. And this is because of the transitive property of parallel lines. That's that first theorem, that nickname. So now, these two are gone, and we have A is parallel to C, and C is perpendicular to D. So now the question is, how do A and D relate? Well, D is perpendicular to one of the parallel lines C. That means D is perpendicular to A as well. So what does this mean? This means that A is perpendicular to D as well. And this is because of the perpendicular transversal theorem. Perpendicular transversal theorem. Or the fact that D is perpendicular to one of the parallel lines, so it's going to be perpendicular to the other parallel line. Remember that idea. So there's your answer for part A. Now B, again, we'll go left to right. Let's start here. What does A being perpendicular to B and B being perpendicular to C mean? Well, A is perpendicular to one of the parallel lines. Therefore, it's perpendicular to the other. A is perpendicular to C. And this is, again, that perpendicular transversal theorem. So now I have A perpendicular to C, and I have C parallel to D. Again, A is perpendicular to one of the parallel lines. Therefore, it's perpendicular to the other. A is perpendicular to D. And this is, again, by the perpendicular transversal theorem. Okay? So there you go. And again, this is not the only way. I just went left to right. You could have gone either way. I would suggest if you see a lot of parallel lines, you try to use the transitive property of parallel lines first. But it does not matter how you do it, as long as you arrive at the same conclusion. Okay, hope this helped. We'll see you on Thursday.